Hello, and thank you for joining in on this webinar this morning. My name is Tony Gabriel. Some of you may recognize my name from my time in technical support or my current position in the Building Automation Group, where I work alongside Steve Atchison, Shane King, and Kay Decker. Today I will be presenting DriveWizard HVAC, which is a no-cost software. DriveWizard HVAC is a window-based software tool designed to make commissioning and troubleshooting of Z1000 and Z1000U drives and bypasses, most V1000s, and most E7 Yaskawa drives as simple as possible. DriveWizard HVAC provides user-friendly tools for viewing, manipulating, and exchanging data with the drive. This data can be retrieved, changed, stored, and graphed, and we will go over all of these features. I'll start out with a short PowerPoint highlighting the benefits and features, how to find and download DriveWizard HVAC, and the different ways to connect to your PC. Whether you are one of our distributors, a service tech, or an end user, using DriveWizard HVAC will help you feel and look like a pro. And throughout this presentation, you're going to be able to pose questions in the chat box. You should have access to a question box. You can send in questions. Hopefully most of those will be addressed throughout the presentation. If not, at the end, this presentation is going to be about 45 minutes long, and then we'll have a 15-minute Q&A, and we'll answer some of the questions live. If we do not get to your question, it will be answered on a personal basis. So let's get into the PowerPoint here. So as I mentioned, supports Z1000 standalone and Z1000 bypass, most V1000 and most E7 drives. There's several ways to connect. The serial, you can use the Yaskawa Y-stick, you can use a USB cable, standard printer cable, or the Ethernet connection, provided you have the optional board. DriveWizard will automatically check for updates upon starting. Benefits in operation. Again, it simplifies commissioning and troubleshooting Yaskawa drives. You'll be able to create, open, and save drive parameter projects, and then add project name, user info, and project information. There's an Ethernet network configurator, 6-channel real-time trend recorder, 4-channel real-time monitor, status and diagnostics panel. You're going to be able to print or export these parameter reports. There's a parameter search function, links to the manuals, provided you have an internet connection, and then you can easily email the parameters and then compare parameters. We're going to go over most of these features today. Here's just an example of the trend recorder, and I'll be demonstrating that soon. So finding DriveWizard HVAC, probably the simplest way is to log on to yaskawa.com, and in the top right search bar here, just type in DriveWizard HVAC. It should come up at the top of the list. And there are also other helpful links, such as DriveWizard HVAC system requirements. So if you were questioning whether your computer is compatible with DriveWizard HVAC, you could review the requirements there. Then you're going to want to download the software here. And then you're going to have to allow the necessary changes to take place. Now, connecting your PC to the drive. Again, there's 4 different types of connections. Here is the USB cable type A to B. It's a printer cable. You can use the Yaskawa Y-stick here. Here's an Ethernet option shown with the dual port, or you have the different serial cables. If you do use the serial connection, you're going to need a third-party USB to serial adapter. We're going to get into the details here. The USB printer cable, you're going to have limited functionality. You're going to be able to read and write parameters and access monitors. But this is only going to connect to the Z1000 and Z1000U drive. No bypass cabinets. Here's the Y-stick. Again, limited functionality, read and write parameters, access monitors. This will connect to the drive or bypass. Really any drive that has the RJ45 port, that would include the V1000 as well. Here's the Ethernet option card. This is the dual port shown. The single port would be the part number SI-EN3. And with this as well, limited functionality, read and write parameters, access monitors. This will only connect or allow connection with driver bypass if equipped with this option card. And here's the serial cables, and this is the type that I would recommend, and I know our training group pushes this as well. You're going to have full functionality with these cables. So not only read and write parameters, and access monitors, you'll also be able to perform drive maintenance and mainly update firmware. And I need to mention that that is rarely needed. If you do happen to log on and see that you have an older firmware and there's a newer one available, that does not mean that you have to update your firmware. So keep that in mind. And the different cables, the part numbers and the serial to USB adapter, there's a couple part numbers here listed. Our training department, I think, lately is pushing this Triplite part number USA-19HS, or the Prolific part number. That's actually what I'm using today. It's part number 26886. Others are available, and you must use their driver. The part numbers for the cables, the green cable, here's the part number for it. It's a boot cable for 1000 series drives, and this is recommended to recover a brick drive. So the brick drive would occur if you were flashing a drive, updating the firmware, and the flash was interrupted. Then it would be considered a bricked drive, and you would need this green cable. You're going to be able to read and write parameters with this. This cable doesn't work for flashing 7th gen drives. And here, the blue cable, there's two different versions. The UWR 00468-1 or -2, different capabilities. The -1, you can flash 1000 series and 7th gen drives, but you cannot recover a brick drive. And then again, you'd be able to read and write parameters. The -2, you can't flash a drive with this one. I would recommend the -2 for most customers, because again, you're not going to be needing to update firmware. That's very rare. And if you did happen to need an updated firmware, I'd recommend you contact an authorized service provider or an ASP because you can get into trouble if you do it wrong. Worth mentioning, never plug the Ethernet cable from your COM port directly into the drive. I know, it might look like, hey, I can plug it directly in and it's no problem. You're going to damage the COM port on your computer if you do that. So never plug that in. You need to interface it with the serial cable or one of the other connection types that we ran through. Here's a typical communication error, and I'm going to demonstrate this connecting. This is probably one of the main errors that you're going to see, and it's making sure that you're in the right COM port. So this would prevent you from getting online with the drive, and I'll demonstrate that coming up here. So connecting the DriveWizard, if you are unable to connect for whatever reason your PC to the drive, you are always able to contact the drive's technical support group at 1-800-YASKAWA, and you can also email them at drivesupport@yaskawa.com. If you do want further information on DriveWizard HVAC, this webinar is recorded and you will be able to watch it. Also, in the fall of 2018, there's going to be an ELM, an electronic learning module, that's going to be released. So keep an eye out for that if you do want more information. So I'm going to be connecting, I have a demo unit here, Z1000. It's a 3 horsepower tabletop unit. And I'm going to be connecting using the serial type connection. So we're going to move on to the DriveWizard program itself. Open up the program here. All right, so first thing is that we want to connect to this drive. So you're going to open up this drive selection and communication setup. And I'm going to change my COM port. I know this will work, but I'm going to change this to COM port 5 to demonstrate that error I was referencing earlier. And I'm going to click the test button here. So here you see that we're not able to connect. There's a communication error. So what I'd recommend is to get into your device manager. Let's see here. And then find your COM port selection here. So I can see that the computer is recognizing the Prolific USB to serial converter, and it's in COM port 4. Another thing to keep in mind, if you didn't have the driver installed for the serial to USB converter, you would see a yellow triangle here, and I believe would have an exclamation point in it. That's a clue that you don't have the driver installed for your converter. So as I mentioned, you'd always need to have the driver for whatever converter that you use, and then double check your COM port. If you take care of these couple issues, connecting the DriveWizard is pretty much pain-free. So we're going to modify this, go and select COM port 4, and test, and it looks good. So we should be able to connect to the drive. So it's going to run through some taskbars here. Just be a minute here. You can also work offline. There was in the drive selection and communication setup, there's a tab that allows you to work offline. And you could build, what I'm going to demonstrate now is just basic selecting parameters, finding parameters, looking at modified constants. And what I'm doing now, you could select offline and build at your desk in your office, and then upload it later to a drive. Even if you didn't know the drive, or you had multiple part numbers, you can build a parameter set using a 3 horsepower drive and then upload those parameters to any size drive. So right now we're looking at the parameter tables. If you're familiar with the Yaskawa drives, you'll recognize some of these parameters. And if you happen to know what you're looking for, let's say acceleration, that's a pretty common one, C1. So we can go into the subset C1, you have C2, C3, and so on. But I know that C1 and C101 and C102 are our XL and decel times. So if I wanted to change those, I could just double click and then select the value. So we'll just change it to 60 seconds. And you have your range here, so it's kind of a handy note. And then I'm going to change our decel time. We'll do 60 seconds there. Now, let's say maybe you wanted to limit the upper speed, the maximum output from the drive. Maybe you only want it to run at 50 hertz or something less than 60 hertz. But you're not sure where the parameter is or what you're looking for. So on the Edit tab here, you can click here, the Find Parameters. And let's just try maximum. I'm going to search, we're trying to search for a term that's actually listed in the parameter itself. And as an example, so I'm looking here, and anything with maximum came in, populated here, but I don't see the parameter that I'm looking for. I don't see like an upper limit, so let's try upper. And instead of looking at using the binoculars, I'm going to use this active search bar at the bottom. So anything that uses the term upper would immediately populate here. And now I see that, here it is here, frequency reference, upper limit. So if you're somewhat familiar with the drives, you should be able to find most of the parameters that you're looking for by just knowing the terms. So we can click on D201. And if we wanted, let's say 54 hertz, we would change that to 90. This is a percentage of 60 hertz, so always keep that in mind. You have the percentage, the scale here, and then the range. And then we'll write and save that to the drive. And now that I know that that was D201, I can drop into the parameters and then the subsets. So I'm going to go into the D2 group, and here's the lower limit. And that's what I was looking for. Well, let's put a lower limit in here as well. So we'll do 34%. And that's about 20 hertz. So we'll save that. And let's just do one more here to demonstrate the active search. Another common parameter might be auto restarts. So let's just type in restart. So we'll look through the parameters here, and here it is here, number of auto restart attempts. It's hidden in the L5 group, so if you weren't familiar with it, easy way to find it. You can do 0 to 10, so we'll put 10 auto restarts in. And we'll save that. And you see here, these parameters, I just changed the D201, D202, they're highlighted in red. That indicates that this has changed from default. So you have the default setting here at 100%, and we entered 90% and then 0, and it became 34%. DriveWizard is pretty handy in that you can isolate the modified parameters by clicking on modified parameters in the left column here. So it brings up anything that's been changed. So if you're troubleshooting a drive, I know from my time in tech support that this was valuable information to at least get a baseline to see where the drive was, and then to start troubleshooting it if it wasn't starting or accelerating or what the problem might have been. What I'm going to do now is just save this. And you know what, before I save that, let's do project info. So here's where you'd add your project info. So maybe this is for North High School. And maybe the contact is Jeff Smith. And you can put in your information. This would be for AHU 1 through 4. And then we could save this file. And then it would be saved as North High School. You just save it on your desktop, create a folder. And I was using this, it's already bringing me in here. This was my sample. I've been practicing with this for this webinar. So we'll save it here. And I'm going to replace it. And what's nice about that is, like I mentioned earlier, that let's say we create this working parameter set, and maybe that's for AHU 1 through 4, but you have additional fans or cooling towers or pumps. Maybe this parameter set will work for the others as well. You could then save this again as pumps 1 through 4, cooling towers, and so on. And exactly what I did here could be done by working offline by selecting this tab here, the drive selection and communication setup. And then to select the drive and work offline, you would just populate information in here. But as I mentioned, if you didn't know the drive, even if you didn't know the voltage, you could just use the default setting here, create that same parameter set, and then when you want to upload it to the drive, it would just, if it wasn't the exact drive with the voltage or horsepower, you're going to get a KVA dependency error that you can click through and allow these basic parameters to be uploaded to any size Z1000. All right, let's see here. Okay, I'm going to move on to monitoring status and data trending. Oh, you know what? Before I do that, let me just mention the export feature. This parameter set, you could save this as a PDF, and you could actually email this as well directly from DriveWizard if you had an email connection or internet connection. But something handy would be to send this to drive support. Let's say you weren't sure why your drive wasn't running. So you could email this modified parameters. It would populate with the information, the drive size, and then you could type up your message and say, hey, I'm working on the Z1000 drive. It's not starting, or maybe it's not accelerating, or maybe it's not running the 60 hertz, something simple like that. And then tech support could evaluate these parameters and say, hey, well, you're not getting to 60 hertz because D201 is set at 90%, just as an example. So it's it's handy to know this. Okay, let's move on. Let's see here. You have the different tabs up here. I'm going to stick with this Startup and Diagnostics tab for now. And the different selections here, so you have Trender, Monitor Panel, Status and Fault History, Drive Control, and Motor Tuning, or Auto Tuning. We're going to demonstrate the Trender here. And as I mentioned earlier, I have a demo unit here. It's got dip switches and speed pods, so we'll be able to run this little quarter horsepower motor with this 3 horsepower drive. So I started it up, and I'm going to start the Trender. So you can see here we have a bunch of different lines that we're monitoring. And if you look here, we're monitoring 6 different monitors. So the red line represents output frequency. Blue is frequency reference. Black is output current. Green, output power, and so on. We're monitoring S1, our digital input run command. And then the raw value on U113, terminal A1 input. So if you were maybe troubleshooting a drive that wasn't running, you could come in here and check your reference on A1. You can see how the light blue line is leading the dark blue line because that's our input value. It takes some time for the drive to respond to that input. And then if I open the run command, you can see it going high and low there. and then you can see the drive is ramping up. So it can be handy information. This can be recorded as well. If you wanted to, you could record this. Now I stopped it, but if you were troubleshooting a drive and maybe it was running intermittently, it was stopping, losing a speed reference, maybe a run command, but you're not sure, you could highlight these different monitors, record, and then come back and review it later. I'm not going to go into the detail, we just don't have the time, but worth mentioning. So I'll turn the drive off. We're going to look at the monitor panel now. Pretty similar to the Trender. You can change the different types of meters. You can select from a gauge, a sliding scale, the Trender, or the LED display. So the first three are LED, and then we have a mini Trender here. I'll start the drive again and start monitoring here. And I'm changing A1 input. We're bringing A1 down to 0, so you can see meter 2 is 0, but our frequency reference is 20.4 because of that minimum speed. And we bring it back up, and then we're monitoring DC bus voltage and then output current. This is an 11 amp drive. It's a 1/4 horsepower motor, so a very small motor, so there's really no deflection in this gauge here. But yeah, just another demonstration. Let's close this. And the status and fault history. You have a real-time feed here if you wanted to start this. I'll just demonstrate it quickly. It does take time for this to update, but you see here U102 is starting to accelerate. We have a 54 Hertz reference. It's telling us that S1 is active. That's our run command, and then our output frequency is starting to ramp up. What's nice about this is you can have easy access to the fault history and then the fault trace. So the fault history is the last 10 faults that occurred, EF3 and OPR, and that makes sense. This is just a demo unit, so EF3 is just terminal 3 being closed. But if you wanted to troubleshoot this, let's say you had an EF3 fault and you didn't know why or what was going on, you could come in here and look at this fault trace history and evaluate what's going on. So right here is our last fault, EF3, and then here's our frequency reference at that fault was 54 Hertz, and our output frequency was almost 14 Hertz. So I know that we were accelerating to 54 Hertz, and I know that based on the input terminal status here, so U211, this is more valuable information when you're troubleshooting. This is the input terminal status for S1 through S7, S1, 2, 3, and 4 from right to left. So I know we had an active run command. S1 was closed and S3 was closed, which makes sense. We had an EF3, so I know we were accelerating, and terminal 3 closed, so that's why we had that EF3 fault. So if you were to send this in to tech support, for instance, by clicking the email tab and putting drive support in here, again, put your message in here, troubleshooting an EF3, not sure what's going on. Well, tech support would look at this and say, well, you have an EF3 fault, S3 closed, and you need to figure out what's on terminal 3 and why it's closing. So maybe I had a safety interlock or something in there. So we'll move on to drive control. Now, this is going to allow us to start the drive from our PC. We click through that, accept the dangers, the potential dangers. You want to make sure no one's standing by the motor. You can turn the drive control on. Click the forward button, and then you can change the speed here. So right now the drive is actually ramping up, and this would be handy maybe if you were commissioning the drive during startup and you wanted to check motor rotation. Be a nice reason to maybe use this. When you're done, if you're done using this, click the stop button and always turn this off. If you were to close this box without turning this off, it actually changes the sequencing control to serial comms. So your speed reference and your run command would be directed to serial communication. And if you were using your digital inputs or your analog speed reference, it's not going to recognize that, so your drive wouldn't run. So you always want to make sure you disable this to prevent something like that from happening. Okay, I think we've covered most of that. I'm going to cover auto tuning We can get into that right now, actually. It should go pretty quick. I'm going to do just a terminal resistance. This is a stationary tune. And this is a small motor. Sometimes it can be problematic to auto-tune. It's a 1/4 kilowatt. It's about 1 amp. But just for demonstration purposes, we'll see if we can get through this. So we'll click Run here. It's going to take a minute. So it's starting here. There's a progress bar there. Let's see what we get. And it was successful. Okay, so you can see here it populated these different motor parameters, and by entering the motor data, so E201 was automatically entered when we entered the amps, which is a parameter that you always have to set. If you have a standalone drive, you always have to configure your motor amp so the drive can protect the motor. And then if you wanted to stick with these parameters, which there's no reason we shouldn't, you can transfer the tuning data to the project by clicking here. So that should be transferred in. And let's confirm by looking at the modified parameters now. So now you see the auto-tune parameters are mixed in with the parameters that we originally changed. And by creating and saving the original file with the original set of base parameters, when you would upload these parameters to each drive, even if you had the same horsepower, you wouldn't want to use the same auto-tune parameters. You would want to individually auto-tune each motor. So you could upload the base parameters and then connect to the drive with DriveWizard on your PC, auto-tune, and then transfer the motor-specific data with the base parameters into that drive and do it on a one-on-one basis. So you'd have the custom tuning, but the base parameters would be the same. And that pretty much covers that section. I'm just going to mention really quickly the DriveWizard HVAC database and custom firmware. There is some custom firmware that exists for some of the different distributors. If you check here, so this was in the Options tab, and then under the Data tab here, any drive or bypass cabinet with this firmware, this is what's on this DriveWizard program on my computer. If your drive or bypass has what's listed here, you should be able to connect. And for example, the firmware flash would be available in the monitors, and on Z1000, for example, it's U125. And this drive in particular, I believe, is 1020, so that's 1013 to 1020. So just worth mentioning, if you had custom firmware and you wanted to use DriveWizard, it is possible. You'll have to contact your distributor if you're having a problem logging on and you find out it's custom firmware. Your distributor will be able to help you acquire what you need. It's an add-on database. All right, I'm going to get into the Application Wizard and Converting Tool. Application Wizard, this is going to be handy if you're not familiar with Yaskawa drives. And maybe even if you work with them often, maybe you only know a handful of parameters, or you still have trouble understanding the basic parameters, what you need to get a drive started. This is going to basically walk you through commissioning and starting up a drive. So we'll start out, and I'll run through these steps here. So first here is A102 control mode. It's set up for V by F, which is typical for a fan or pump, so we're going to leave that. Motor full load amps. So this addresses E201 right away. So we'll set that at 1.2. Base frequency, typically you're not going to change this, 60 hertz. We're going to leave that at default. Click next step. And this is here. How would you like to set the drive speed reference in auto mode? Okay. You have several selections here. You can pull it from the keypad, terminals, serial communication, or the network option. We're going to leave it on terminals, and then you have a quick reference here, A1 or A2. If you were using a speed pot, the basic wiring here, if you had a 0 to 10 signal, it would be A1 to AC, or 4 to 20 would be A2 to AC. And we'll move on. here is how do you want to start and stop your drive in auto mode. And here is one is selected, so it's looking at the digital inputs, S1, and you have the little icon, little schematic here. When you close S1 and SN, that's going to be your on command. If you had serial communications for your on command, you could select here, or the option card, maybe if you had the Ethernet option card I mentioned earlier, or we're going to leave it on the digital inputs. Stopping method, another parameter you might want to change, coast to stop. Let's set it to ramp to stop. Reverse disabled, pretty typical for a fan or pump. We'll leave that as is. You can change your XL and your decel. We'll change those to 60 seconds. And some fixed references. Maybe we want a preset speed in here. Let's do 35 hertz and we'll do 45 hertz. And if you're familiar with Yaskawa drives, you would know that these fixed references, when you close S5, you're looking at D102, or S6 would pull D103, and those would be fixed references. And here are the upper and lower limits. We addressed these earlier. If you remember, 90%, that was 54 hertz, and 34% here was approximately 20 hertz. So moving on, here's a PI control setup. Now, PI control can be a little confusing. It's easy to configure if you're familiar with Yaskawa drives, but don't be misled by this. This is not going to completely configure PI control for you if you happen to need that, and that's using a transducer and setting a set point and having the drive actually modulate to the feedback. You will still have to configure scaling and a set point. So yeah, don't be misled to think that this is going to set your PI loop completely. We're going to move past this. If you wanted to change your digital inputs, the functions, you could do that here. I'll just select, open the drop-down window here for S7, but you can select any of the digital inputs. This would be the H1 group, and all of them are listed here. We'll leave these at default. And then the same with the digital outputs. So M1 and M2, you're going to have a close during run. M3 and M4 is 0 speed. And M5 and M6 is a speed degree. So once the drive gets up to speed, then these would close. And if you wanted to change these, you could select from the H2 group. Close that. Oh, whoops, I didn't mean to do that. Oh, I think we were finished. Sorry about that. Okay, so we're transferring those parameters to the active program. Actually, I think I did miss one step. Let me just go back here. Yeah, okay, there was a couple more things. I'm just going to quickly talk about these. We're not going to change these, but feedback loss detection, if you wanted to set that up. And auto restarts, you could enter 10 in there if you wanted. And then the final one, here it is. Transfer. Let's do this now to the application wizard. Okay. So now those have been transferred. All right. I want to make sure I close that out. All right. And that is your application wizard setup. So if you wanted to use those to set up a drive, it can be handy if you're not familiar with the drive. One more thing, we still have some time left here. I want to talk about the converting tool, and what that is let me make sure that we're disconnected from this drive. So what I do is start up in diagnostics. Whoops. Or drive selection and communication setup. I selected the drive to work offline. I wanted to just disconnect from that drive. I'm going to open up a DriveWizard file that I completed. I built this. It's an E7 PI loop. I'm not going to save that active project. So right now, I'm opening up this program. This is a parameter set for an E7 with a PI loop. And I wanted to demonstrate what DriveWizard can do. Let's see here. So I went into Edit and Parameter Overview and selected Modified Parameters. So I'm looking at these, and I can tell right away this is an E7 drive based on the scaling. So B520, this is how we set the scaling and decimal point. This is actually 5.0 scaling with a set point of 1.5 inches. So the transducer was 0 to 5 inches water column. And how we arrive at 5.0 is 50 is the unit, but then the 1 here represents the decimal point. And to convert these over to Z1000 could be problematic if you weren't familiar with how to interpret this data. But DriveWizard will automatically convert this to a Z1000 project. So you select the Convert tool here. And so this E7 was a CIMR E7U 200 volt class 7.5 kilowatt, which is a 10 horsepower drive. And now I'm going to select the drive that I'm going to convert this to, so Z1000, and let's select the lower horsepower here. Let's say that you had this E7 and something happened to it, maybe the motor went out, they realized they didn't need as big of a motor or something changed, but now they're replacing it with Z1000, but they want the same, they want to use the same transducer, same set point, scaling, everything's going to be the same except maybe the motor and the drive is changing. So we're going to convert this to the Z1000 at this 3 horsepower range. And here's, I mentioned this earlier, there's a motor setup dependent, KVA sizes are different. We can just click through this, and now it's converting that base set of parameters to Z1000 parameters in PI loop. Let this run through. And it asks us if we want to view the conversion log. So I'm going to look at this and just explain it and kind of show the value in this tool here. As I mentioned earlier, that B520 was set to 10,050. As you can see here, in the E7, it actually represents 2 parameters in the Z1000. So B538, from 10,050, DriveWizard HVAC determined that B538 now needs to be set to 50 based on 10,050. And then B539 needs to be set to 1 because of this digit on the left side here. So the scaling now is still 5.0. And the set point, for example, remains the same, and it's the same parameter, B519, 1.5 is 1.5. And most of the other parameters are going to remain the same. You can see here a slight difference for A2. H309 became H310. Everything else basically remains the same. But if you didn't know, this is really valuable if you were attacking a project such as this. So we can transfer this converted data to the active project. And we're not connected to this drive because I was working offline. So what I'm going to do is write parameters. Let's see here. Overwrite. And now we should be uploading these parameters to the drive. Just be a minute here. Much quicker than getting the tech manuals out and going parameter to parameter. And that should be it. Now we're looking at the mods. And they are here. And here they are, B538, B539, and so on. So that's pretty much covers that. And I believe I've pretty much covered everything. A couple minutes early here. If you have any questions, I'm going to mute the mic here, and I'm going to open up the Q&A box, and I'll start addressing questions if there are any. Or if you have any I didn't address, submit them, and then we'll try to answer them live, and I'll demonstrate here. I'll be back in a minute. Thanks. Okay, we have a question wanting to know a little more specifically with the printing a PDF copy of modified parameters. Let's see here. So we go to modified parameters. They're highlighted. We happen to be on the same page here. And I'm going to go to export. Let's select PDF. And then you can save it as a whatever you want. So I'm going to do, let's see, we'll just knock this out and I'll do PI parameters, and then we'll stick with that North High School AHU 1, 2, 3, 4. We'll save that under North High School, so we'll go back. Let me open that up. I'm going to show you what that looks like. And I think it's this one here. So if you were, let's say you're a service technician and you built this transfer file from this E7 and you wanted to keep this parameter set in your cabinet, this would be a nice way to do that. And this shows the modified parameters here for future reference. So that's and again, you could send this to tech support or email it to your customer. All right, we have a question that's asking for the different cables. You should have had a link on the invitation that would bring you to this page. I'm going to open it up on our website here. It's under the Solution Center. So I'm going to search for DriveWizard HVAC. Actually, maybe just DriveWizard cables. Let's see here. Yaskawa Solutions only. Let's see. Yeah, here are the part numbers. I think there's a, well, the main information is here. As I mentioned earlier, the 468-2 cable is probably the one that most customers are going to need, and that's all they'll need. This -1 is for flashing. If you do mess the flash up, you'll need to get the green cable, to boot it, to reboot the drive basically, if you brick the drive. I would not recommend anyone flash, and that's why we're not really addressing it. But again, the UWR 00468-2, and you should be able to contact your distributors. If you are a distributor, contact your inside sales rep if you wanted to order that. Something else I'll mention here is this knowledge base, and that's what I'm actually looking at right here. What this is information that's been compiled over the years from tech support, where we've just created documents, basically FAQs, frequently asked questions, of issues, problems, anything that's really come into tech support, we've created a document for. So if you log on to yaskawa.com, whoops, I'm going to do that. Here we go. In the Support and Training tab, Solution Center right here, click on that. It brings you into here, and you can highlight only the Yaskawa solutions by selecting this. And let's say you want to know how to set up preset speeds. Let's see what we get here. And any document that's been created, with preset speeds in the title or the wording would pop up here. So right here we see Z1B or P1B bypass, multi-step speed reference. So if you had a Z1000 bypass or a P1000 bypass, and you wanted to set up maybe up to 4 different preset speeds, you could come in here. It tells you what you need to program on the drive, how you open and close the digital inputs, where the speed reference comes from on this table here. and some other helpful information. And again, this applies to P1000 bypass and Z1000 bypass. I searched earlier for the cables, just DriveWizard cables. And you'll see there's several different windows here. Obtaining, installing, and using DriveWizard IQ. Here is DriveWizard HVAC. Click on this. Here it gives you the system or specification and features, the free download here, the system requirements, lists the cable again. This is probably the page that you're going to want to look at. If you're interested in the cables, if you need the program, specs and features, this is what you're going to want to refer to. Someone's asking for a copy of the PowerPoint, and I will be able to send that direct after the recording is published. Again, this is recorded, so the PowerPoint will be in the recording as well, but I can send that directly to you, yes. I'll make sure to record your email address and create a PDF of the PowerPoint. Someone is asking about the serial, the USB adapter. This is the best one, and what software is and training is recommending to use is this trip light part number, this USA-19HS. That seems to be the most problem-free. And you should be able to Google that. Let's do that here. USA-19HS. And there you go. You have the different part numbers available here. So that's what it is. And I just happened to notice this part number was brought to my attention from someone that was actually watching the webinar, thank you, that these two numbers were transposed, this 6 and 7. It should be 76, so we're going to get that corrected, but it is correct in my PowerPoint. So good eye out there. Thank you. Okay, a couple more requests for that PowerPoint. Again, I'll be able to send those out. So if you do want it, just request it in the question box, and all that information will be sent to me, and I'll send it out today. I should be able to send it out this afternoon. And I think that's it. There's nothing really else coming in. So hopefully everyone got something out of this. Any other questions, just submit them, and we'll answer them on a one-on-one basis. And I want to thank everyone for participating in the webinar today. Thank you.